Let's explore what object-oriented programming is and how it's different from procedural programming, which is what we've been doing. We're going to explore words like class or classes, objects, attributes, and methods, and how they relate to object-oriented programming and some of the overall benefits or reasons why we would like to write code using what we use term as OOP, or object-oriented programming. So let's get a general idea of what it is and how it works. All right, so before we've done procedural programming, and the idea behind procedural programming is we just pretty much write our code. We go line by line until our code is finished, and then we end. And if we are trying to create some variables or trying to define, for example, Fluffy here, we have to create quite a number of variables to describe Fluffy. In other words, here I've created some variable names. I created dog1.name equals Fluffy, dog age is 3, dog1 weight is 5, and then I wrote this little method that gets Fluffy to speak, and I send Fluffy's name into the method, and then Fluffy's names prints out. So that's all well and good, I suppose. But what happens if I then want to create another dog? All right, well, there's our new dog. And so in other words, for what we've done in the past with procedural programming is, all right, well, I've got to address the new dog, so I need to create some new variables for that dog. So I'll create another variable, dog2 name, that's going to keep track of Goldie. These names are completely unrelated, so I could even accidentally spell dog2 NME, or wouldn't be consistent for sure. Dog2 age equals 8, dog2 weight equals. So I'm certainly keeping track of certain properties or characteristics that define each of these dogs, but I have to declare lots of different variable names that are really unrelated to each other to maintain all the individual data for both of those dogs. That's fine. That's what we've done. It's been working. Here is another way that we've been looking at it. We have been doing arrays. So here is a multi-dimensional array that's keeping track of Fluffy, and I have to remember that the second element is I think it was the age, and the third element was the weight, and so anyway, it certainly worked, and then I could print out the Fluffy and the Goldie. So that certainly worked, but quickly it's becoming inefficient if I need to keep track of more than 2 dogs, if I have another odd. I think you get the idea. So we're going to introduce this concept of object-oriented programming. And instead of thinking of things now in terms of each individual variable like we just did, now what we have to start thinking about is creating, well, first we're going to create what's called a class of the dog. In other words, let's think of all of the things that would make up a generic dog. In other words, what characteristics or methods does Fluffy and Goldie both share in our prior example? So if we were just sort of to think of a generic dog, what things would make up a generic idea of a dog? Well, based on what we just did, a dog generally has a name, it has an age, it has a weight. So all dogs most likely have that. And so we call these things properties or attributes. These are characteristics that describe the dog. Every dog has, like Fluffy had its own name, the Golden Retriever had a Goldie name, they each had their own age and they each had their own weight, but they each had individual variables that describe those things. So let's start thinking about how can I create what we call a class, which is a general blueprint, or I guess blueprint's the best word, of a general boilerplate of what it takes to create a dog. So all dogs pretty much have a name, age, and weight, and especially in the code that we're going to write. What else does those dogs share? Well, they both speak, they both eat. So I don't want to write individual methods for each of those. Every dog would speak and every dog would eat. So if I could write what we're going to call an object, but if I could write a class that holds all of the characteristics and the property or the methods of all things that all dogs share, I would call that a class. So that's what we're doing here. We're creating this class, we're going to call it dog, and notice that I'm calling this class capital D for dog. That's not, you don't have to do that, but it's good, one of those good coding practice things. So we're going to create a blueprint of a dog. And the idea is very similar to if you're creating a blueprint of a car. Let's say if I design what a car is supposed to look like, I can stamp out a bunch of cars based on that blueprint. Or a house, I can create lots of houses from a single blueprint. Each house or each car is going to be a little bit different. Just like my dog, every time I create a dog, it's going to be a little different, but they're all going to share these characteristics, these properties or methods. For example, let's look at our dog. What was his? Fluffy. I'm going to create what's called an object. I'm going to create this dog object, and I'm creating it from this blueprint or from this class dog. And to create this fluffy object, this dog object, this is what we would do in Python. We're going to write the variable name. In this case, I'm going to call this dog1. And we use the equal sign and the capital D, so we're matching the class name. In other words, and then the parentheses, that's important, and you'll see why later. So create from this blueprint a dog object. And because we've created this object from this blueprint, Fluffy is going to receive all the properties and the methods that were defined in the blueprint. So just by creating this object, just by creating this dog object, automatically all I have is a variable named dog1 that receives all of the properties and methods from the blueprint that it was created from. So right away, we don't have to create new variables for this Fluffy. We have to define the individual values for the variables. In other words, now that I have dog1 is the variable name I gave this object. So I'm going to say dog1, I'm going to use this period notation, and I'm going to refer to the variable that I got from the blueprint. So dog1 name is equal to Fluffy. So now this object is getting variable names from the blueprint or from the class, but I can assign this object individual values. So dog1 name, this object's name is Fluffy. This dog1 age is 3, and this dog1's weight is 5 pounds. So likewise, this dog can speak. So this dog has inherited, I don't want to say inherited, but gotten a method from its class. So this dog can speak, and this dog can eat. So what if I want to create another dog? Well, if I create that same dog from a new dog from the same class, I'm going to create a new dog object. So I'm going to call this variable dog2 equals, and this is how we create a new object from the class. In other words, a new dog from our blueprint. We use this equal capital D because that's what I called this class. And then the parentheses. So let's create a new, what we call a new instance or a new object of this dog. And so now we have dog2. Dog2 gets the same variable, age and weight. Dog2 also gets the method and eat. And all of these values then that we assign will be specific to this dog. In other words, we can now give dog2 name, which you got from the class. Name is Goldie. Dog2 age is 8. Dog2 weight is 85 pounds. Dog2 can speak, and dog2 can also eat. So what we're doing then is we're creating, just to kind of reiterate, a blueprint which we can create multiple dogs, but we don't have to keep recreating variable names and recreating the wheel, so to speak, when we can just create the things that are generic to all of our dogs. We can get them from a generic blueprint or what we call class. So what would be a good way to implement? How is this going to benefit us? Well, let's look at this idea. Let's say that we're needing to develop some software for Patsy's Pet Parlor. And Patsy's Pet Parlor does quite a number of services, but we're going to look at a dog grooming service and a dog boarding service. So these are two different files. This is a boarding.py file and a grooming.py file that are very unique because we're looking at doing different code logic if we're grooming a dog versus different logic if we are boarding the dog. But the characteristics of a dog are the same. Whether we're grooming the dog or whether they're boarding the dog still has those same characteristics that we defined in the blueprint. So if we want to create a dog in dog grooming or in dog boarding to keep consistent, for example, all of our files are going to have a variable called name, age, weight. Both of these programs are going to have access to the dog speak and eat methods. Because we've created this blueprint, we have consistency of how to define a dog across both files. So now that means that in this py file, we don't have to create this example we saw at the beginning where we have a dog 1 and its weight is, and dog 2. We're not defining dogs separately in each file. We're recreating dogs consistently from a single blueprint, no matter which file we're in. So this gives us the ability to reuse code and to make sure we're consistent across the board here. So however a dog is defined here, it's also defined here the same way. So that way we can be consistent, for example. In this case, we can see that this dog, if the weight is over 50 pounds, we might charge more for bathing or less because it's a smaller dog. In this case, we're also creating a dog object based off of this dog class, but we're using it a little bit differently. Now we're concerned if the weight is greater than 30, we're going to have to feed the dog more. So we're utilizing the same properties. We can utilize the same methods in either file, but we don't have to recreate the wheel. The blueprint is the same for both, and we can utilize that blueprint in both of our files. So in the next video, let's actually implement this so we can see it in action.